Hello and welcome to your functional skills lecture on 2D and 3D shape. In this lesson we're going to be looking at learning outcome 20 and learning outcome 21, which is understanding and using common 2D representations of 3D objects and plans and elevations. So in this lesson you should be able to explain the properties of 2D and 3D shapes, draw common 2D representations of 3D objects, draw 3D shapes to include plans and elevations. So we're going to go through all of those things. Okay, so the first thing we're going to do is go through some properties of 2D shapes. But before I do that, I just need to explain a few things about lines. Now, a straight line is a one-dimensional shape. It's just got one line. It only has one length. Okay, and a line segment, or just a line, has a finite length. Okay, it finishes. There is a length to this line. So for example, the line segment PQ has 2 points on it, P and Q, and it starts and finishes at those points. Okay, so there will always be a measurement for that 1D line. Now you need to remember that there are two types of important lines that you need to remember. So two lines are parallel, like this one, these two just here, if they do not intersect or touch each other. Now you might remember that from school or whatever, but these two lines are parallel, these two here, because they do not touch and because they're equal distance apart. Okay, now these two lines here, meaning this line and this line, are perpendicular. So these ones are parallel, these ones are perpendicular, which means they're at a right angle to each other, just like a wall could be at the right angle to a floor. They are perpendicular. That's just the terms and the terminology that you're going to need to know. Now then, 2D shapes. 2D shapes have an area but no volume. They are flat. They are usually formed by line segments, meaning that, for example, this square here, not very well drawn square, okay, has four sides, they're joined together and they have measurements. This could be 2 centimetres and this could be 2 centimetres, which is why it's 2D. It has two measurements, okay? It's 2D, it's flat, whereas a line is 1D. It's got no other measurement other than that one from there to there. They are marked with a short line, when two or more lines in a shape have equal lengths, they are marked with a short line like a dash across them. So for example, a square has four sides of equal length and they've got four small dashes just to show that those lines are equal. You need to recognise a range of 2D shapes and their key properties. So there's a table here, and if you'd like to, you can pause the video and see how many of these you can remember. So as an example, a three-sided shape is a triangle. That's the name of the shape. There are different types of triangles, but if it's three-sided, it's called a triangle. What do you think the other ones are called? Giving their generic names. Pause the video, have a go, and press play for the answer. Okay, if you've had a go, let's have a look. We've got quadrilateral, which is the four-sided shape. Now, there are many different types of quadrilaterals, such as a square, a rectangle, a trapezium, and we're going to go through some of these in a minute. Kite, okay? There's different types of quadrilateral. A five-sided shape is called a pentagon. Six-sided shape is called a hexagon. Seven-sided shape is called a heptagon. Eight-sided shape is called an octagon, 9-sided is a nonagon, and 10-sided is a decagon. Okay, so you won't really have to remember too many, there's not lots of different types of decagon, so you haven't got to remember loads of those, but there will be quite a few of these you're going to have to learn. Okay, so triangles then. All triangles have three sides, and there are different types, defined by side and angle properties. Can you name the four types of triangle? So again, pause the video and see if you can write down all the four types of triangle. Okay, if you've had a go at that, here are the four types. We've got a right angle triangle, an isosceles triangle, an equilateral triangle, and a scalene triangle. Let's just have a look at those in a bit more detail. So what are their properties? Here are our 4 triangles. Our right-angled triangle, we must know, has a 90-degree angle. That's how we remember that it's a right-angled triangle. Okay, and it's usually labelled with that little box there. An isosceles triangle has 2 equal sides. Okay, if you can see those 2 lines there. 2 equal sides and 2 equal angles. We remember that it's isosceles because usually these 2 base angles are the same, and then we have a third angle that's different. Okay, and if the 2 base angles are the same, then the 2 sides measure the same. It also has 1 line of symmetry going through it just there. An equilateral triangle is the easiest one to remember as well, is one of the easiest ones along with the right angle, but all the sides and all the angles are equal. So 3 sides measure the same, 3 angles measure the same, and it also has 3 nice lines of symmetry going through it. Finally, we have the scalene triangle, which is all completely different. I remember this one because scalene is quite a strange word, and it just, to me, feels like it's all different. So each side is different, each angle is different, there are no lines of symmetry. Okay, so let's continue. Now, we have the triangles, but then we also have these quadrilaterals, and like I say, there's quite a few different types of quadrilateral. Okay, we're going to go through a range of quadrilaterals now. So quadrilaterals have 4 sides, and there are lots of different types defined by their properties, so such as angles and sides. Here are the 6 you need to know. So the first 2 are easy: square and rectangle. A square has 4 lines of symmetry, rotational symmetry of order 4. It has all equal sides. Sorry, when I say rotational symmetry of order 4, it means that if I turn it around, I can turn it 4 times before it gets back to the way it was. Okay, and then 4 lines of symmetry just means that it's got 4 lines of symmetry. So if you folded it in half, it would look the same. It has 2 pairs of parallel sides, meaning that these 2 are equidistant and parallel, and these 2 are equidistant and parallel. There are 4 90-degree angles: 1, 2, 3, 4. And the diagonals are equal and bisect each other at right angles, meaning that in the middle it would create a right angle. Now, just to remind you then that lines of symmetry means that I can cut it in half or put a mirror down the centre and it would look exactly the same. It means that this side is exactly the same as this side. Okay, that's what a line of symmetry is saying. And the same the other way. Okay, this side is exactly the same as this side. Okay, if that makes sense. I've probably drawn on that so much that you can't tell now. So that's what a line of symmetry is. Now, a rectangle is a little bit different because it only has 2 of them. It only has 2 lines of symmetry. It doesn't have 4. We can't go down the diagonals because they're not, all the sides aren't the same. Okay, so it only has 2 lines of symmetry. It has rotational symmetry of order 2, meaning I can turn it all the way around that way and then all the way around back to the beginning. Opposite sides are equal. So this side is the same as this side, and this side is the same as this side. And then on top of that, it has 2 sets of parallel lines. That way, that way, that way, and that way, which is pretty obvious, I guess. All angles are 90 degrees again, and the diagonals bisect each other. Okay, that means that if I drew a diagonal line, they would bisect in the middle. That doesn't mean that they are parallel. That doesn't mean that they are lines of symmetry, though. So there's the first 2. The next two you've got are a rhombus and a parallelogram. A rhombus is basically like a square that's been squashed a little bit. Okay, but it only has two lines of symmetry. It has rotational symmetry of order 2, meaning I can go 1, 2. All the sides are the same, as you can tell by these singular lines sticking out here. And the opposite sides are parallel, which you can tell by these here. So those are parallel lines, and then those two are parallel lines. Opposite angles are equal, meaning that angle is equal to that angle, and that angle is equal to that angle. The diagonals bisect at right angles to each other, meaning that they would create a right angle just there, and there, and there, and there. Okay? They also bisect the corner angles, those diagonals. So the main things you need to remember are the lines of symmetry, the rotational symmetry, and maybe how many parallel lines there are and that all the sides are equal. And all the angles. And the opposite angles are equal, sorry. If you remember like the different simple properties, then it'll be easy for you to work things out later. Parallelogram. Parallelogram has no lines of symmetry. This is a bit like a rectangle that's been squished a bit. Has no lines of symmetry, but it does have rotational order symmetry of 2, meaning I can flip it around like that and then flip it back round again and it'll be back to the beginning. Opposite sides are equal and parallel. So this side is parallel to this side and this side is parallel to this side and equal. Opposite angles are also equal. So those two are equal and those two are equal. Alright. Again, the most important ones are no lines of symmetry, rotational order symmetry, opposite sides are equal and parallel. I suppose for all of those you need to remember. Or at least try your best to remember. It's not the end of the world if you don't remember every single fact about every shape, but the ones that I'm starring, it would be useful for you to remember. Right, the last two, we have a kite and we have a trapezium. A trapezium comes up quite a lot, especially they ask you for the area of a trapezium. We're not going through that today, but what we will go through is just the properties. We'll be going through the area of trapeziums later. So a kite has one line of symmetry going straight down the middle, okay? It has no rotational symmetry, meaning we can only bring it all the way back round one time. If we rotate it, it's only going to slot back into its shape once we get back to the beginning. It has two pairs of adjacent sides that are equal. So this is equal to this, and this is equal to this. The diagonals do not bisect each other, but cross at right angles. Okay, so finally then a trapezium. Trapeziums have one pair of parallel sides. Okay, so usually the top and bottom are parallel. Okay, this one's kind of been flipped on its side. And then these two sides will be of equal length, but they're not parallel. It doesn't have any lines of symmetry all the time. Okay, so for example, this one has a line of symmetry, but this one does not. Okay, so it depends on the way the trapezium's been drawn. It has no rotational symmetry, meaning we have to bring it all the way around before it slots back into place. Okay, and now your special case, like I say, is an isosceles trapezium has one pair of equal sides and one line of symmetry. Now, when it says isosceles trapezium, it means that these two measure the same. And because those two measure the same, it will have a line of symmetry. Okay? Okay, so we've looked at some properties of 3D shape. Now we're going to have a little bit of a closer look at symmetry. You'll need to know about two different types of symmetry in 2D shapes. Reflection symmetry and rotational symmetry, which we've already touched on a little bit. Reflection symmetry is when a 2D shape has reflection symmetry or line symmetry. A mirror line means a mirror line can be drawn where one half of the shape is the reflection of the other half. So for example, like if I drew this might not be great, half of a butterfly, if I put a mirror down there, it would then create the exact same shape, obviously not perfectly for me, down there. on that side. Now if I drew a square and I put a mirror line down there, whatever's on this side would be exactly the same as what's on this side. That's what line symmetry is. The mirror line is called the line of symmetry. These are examples of lines of symmetry in shapes. So a T shape has one line of symmetry. An A shape has one line of symmetry. Okay, if I put a line through there, well, that's not the same as that, so I know that's incorrect. It's not a line of symmetry. Okay. And then if we look at this kind of like random, well, upside down Y, should I say, that's got 3 lines of symmetry because all of these are the same. So technically you'd get a line down there and it give you the same shape as it would if you did it down there, as if it would if you did it down there. And then this F shape has no lines because if I did it that way, that's not the same as that. And if I did it that way, that's not the same as that. So we can't have a line of symmetry on that shape. Okay, so just remember, lines of symmetry are where you can put a mirror and you would get the same exact shape. Now then, when you're in your exam, it might ask you to do something like this. Now you only get 1 mark for this question, as you can see. And it says, shade 1 more square to make a pattern with 1 line of symmetry. Now, this isn't too tricky. I'm going to add the square in so you can see. And as you can see, if I drew a line down there, that would give us the same shape. This side would be the same as this side. Okay. Now for this one it says, shade in the fewest possible squares to make a pattern with 2 lines of symmetry. Now that means that I'm going to have to try and get it so that that side is the same as that side, and so that this side is the same as this side. Okay, so what I've done, I've added a square in the corner, I've then added a square to the centre, and then I've added a square there, not very well, sorry, and another one there. So this, can you see this? And this is the same as this and this. And the same on the other side as well. Alright. Now another typical question is to complete the table below to show the symmetry properties of quadrilaterals. So the rectangle, it says exactly 1 line of symmetry. There's a cross there because rectangles actually have 2 lines of symmetry. Rotational symmetry of order 2, and that's a tick. Now if you want to, you can have a go at this and pause the video and try and draw the diagram quickly, draw the table, and quickly put in your ticks and crosses where you think. Okay, if you've had a go at that, let's go through some answers then. A square. A square doesn't have 1 line of symmetry, it actually has 4. And it doesn't have rotational symmetry of order 2, it also has rotational symmetry of order 4. A kite. A kite does have 1 line of symmetry, and however it doesn't have any rotational symmetry. We can't do anything with the rotational symmetry. A rhombus. A rhombus, exactly 1 line of symmetry, no, and rotational order symmetry, 2, yes. Okay, so a rhombus, it doesn't have exactly just the 1 line of symmetry, but it does have rotational symmetry of order 2. A rhombus actually has 2 lines of symmetry, okay, because it's like a squished square, but because it's a squished square, we can't have 4 lines, we only have 2, because 2 of the sides aren't the same. Okay, so moving on. Now then, when we're looking at rotational symmetry, a 2D shape has rotational symmetry when it looks exactly the same after a rotation of less than 1 full turn. So remember, 1 full turn is 360 degrees. That's a very important thing to remember. Okay, so the order of rotational symmetry is the number of times the shape will look the same as it is rotated through 1 full turn. Here are some examples. So a square. A square can be turned once, twice, 3, 4 times before it gets back, for when it gets back to the beginning and looks the same. So that has rotational symmetry of order 4. A rectangle can be moved once, twice, before it gets back to the beginning and looks the same. So, like, if I drew a dot there, and I moved it one time, the dot would then end up down here, so that's 1. And then if I did it again, it would end up back at the beginning, so that's 2. Okay? So it has rotational symmetry order 2. Now then, the kite must rotate through one full turn before it looks the same. So we say it has rotational symmetry of order 1 or no rotational symmetry. If I put a dot there, there is nowhere that that dot can sit and look exactly the same as it does there until I get all the way round and do my 360-degree turn. However, a regular pentagon has 5 equal sides, which is a rotational symmetry of order 5, because if I put my dot there, it can actually go 1, 2, 3, 4, and then 5 back to the beginning. Okay. It also has 5 lines of symmetry. 1 there, 1 there, 1 there, 1 there, and 1 there. If you just go through all the points of a regular shape, any regular, so regular, where am I? Regular pentagon. If you go from the points, you'll be able to draw the lines of symmetry in there. Okay. Okay, let's look at some 3D shapes then. So, 3D shapes are sometimes called solids. Now remember I said that a 2D shape, let me just grab a pen. A 2D shape is a flat shape. It has 2 measurements, measurement 1, measurement 2. A 3D shape has 3 measurements. Okay, so normally a flat shape, a 2D, will have a length and a width. Length and width. Okay. A 3D shape will have a length, a width, and a height. Okay. Sometimes the width can be called the depth, or sometimes the height can be called the depth, depending on which way around you're looking at it. But a 3D shape has 3 dimensions, whereas a 2D shape has 2 dimensions. Okay. In exam questions involving 3D shapes, you need to be able to work out length, surface area, and volume. We're not going to do that in this lesson, but we will do soon. You also need to identify properties of a range of 3D shapes. So, here are some 3D shapes. These are ones that you kind of need to remember. Don't worry too much about the frustum. You don't really need to know much about that. And yes, but the rest you will need to know, and you will need to work out the area for, or the volume, or the surface area, sorry. Now a sphere, again, that's probably you're looking at more difficult questions there, but sometimes it does come up. So just try your hardest to remember the properties, and once we come to doing surface area and volume, you will understand it in more detail. So, we have some vocabulary that you need to know. Now, a prism. A prism, which I'll show you again on the previous page in a second, is a shape, a 3D shape, with a uniform cross-section and flat faces. This means if we were to cut it into slices along the cross-section, the face of each slice would be the same shape and size. I'm just going to go back a second, because a prism, as highlighted here, this is a triangular prism. Okay, it has a cross-section, which is the face here, and then it has all the flat faces surrounding it, but I would like to say that it's basically then just a length. So this is your face, your cross-section, and if we sliced it down like a Toblerone, it would be the same all the way down. Technically, a cuboid is also a prism, but we don't call it that, we call it a cuboid. And if we cut it all the way down, it would give us the same, and the same for a cylinder. If we cut it, it would give us the same. Okay? So a prism is anything with a tunnel. I like to say a tunnel going through it. So you could walk through this. If you were tiny, you could walk through the tunnel. Okay? Or maybe go into the cylinder, whatever you want to remember it. But that's how I remember what a prism is. It's a tunnel. Okay. Now, A face is a flat surface of a solid. So you need, again, this is just some vocabulary. So you know what a prism is. A face is the flat surface. So here's a cuboid, and here is a face. Here is also a face, and here is a face. It's one of the sides, the flat surface. An edge is where two faces meet. Okay, I'll show you this on another diagram in a minute. And a vertex is another word for a corner. So here is an example of that cuboid I was just talking about. We have 6 faces. Okay, I'm pointing to 1 on here, but a cuboid actually has 6. 1 at the front, 1 at the back, 2 either side, 1 at the top, 1 at the bottom. 6 faces. It has 12 edges because an edge is where 2 faces meet. So for example, this is an edge, this is an edge, this is an edge, this is an edge, so on. And a vertex is basically a corner, and it has 8 vertices. Vertices is how you say more than one corner. And they're all the corners here. Okay, so you know what a corner is. Don't have to explain. Alright. So we know what a prism is, we know what a face is, we know what an edge is, and we know what a vertex is. Remember, your prisms are your tunnels. Not very good at drawing prisms. Now then, we also need to know about nets. So the net of a 3D shape is a pattern of 2D shapes or flat shapes that can be folded to make a 3D solid. For example, we've got here the full solid of a cuboid and then the net version. Now if you can imagine building up the sides to create this shape here. That's what a net is. It's basically all the sides attached together to create that 3D shape. Now I know it seems like there's a lot of information that I'm throwing at you today, but there's just a lot of things that you need to know in order to be able to answer future questions. Okay, so that's how you would draw that net. You might want to do some practice of drawing nets of different shapes if you wanted to. Your most common one is going to be a square or a rectangle. So if you want to have a bit of a practice at doing some of those, get yourself some squared paper, draw yourself a cuboid, and then try and draw an accurate representation of the net. Okay, so can you fill in this table? Now you've got a cube, a triangular prism, a square-based pyramid, and you've got a tetrahedron, which is basically just a triangular-based pyramid. Okay, if I write that down there. Triangular-based pyramid. If you just look at the difference between square-based is square, triangular is triangular. A square-based pyramid, because it has a square base, okay, the net would be a square, and then you'd have 4 equal triangles. Not that mine are going to be perfect here, because then when you fold them up, it creates that shape. Now when you have a triangular base pyramid, the base is a triangle, and then you have 3 extra triangles, which then when they lift up together create the point at the top, okay, into that pyramid shape. Okay, pause the video and see if you can fill in this table. You've got to work out the number of faces, the number of edges, and the number of vertices for each shape. Okay, if you've had a go. A cube has 6 faces, okay, 1 at the front here, 1 at the back, just there, these sides, 1 at the top, 1 at the bottom. This is why using your imagination is really handy with shape, because you can't always imagine what it would look like, maybe folded out. It has 12 edges, okay, we have to look at how many edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 8 vertices. Oops, sorry, that's supposed to say 8, not 18. So 8 vertices, okay? We then have the triangular prism. Now the triangular prism has 5 faces. Okay, so you can see 1 at the front, 1 at the back, 2 either side, and then 1 at the bottom. Okay, so it hasn't got a top one, so it's only 5. Number of edges, so let's just count to check that I've not made any mistakes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And then vertices, 1, 2, 3, 4, 5, 6. Good. The square base pyramid, now I drew the nets out so we can actually work out the number of faces. We've got 1 there, 2, 3, 4, 5. Lovely. 5 faces. Number of edges, 1. Now that you have to be very careful here. Okay, 1, 2, 3, 4, 5, 6, 7. But there's one at the back that you can't see. So there'll be 8. Okay, you can't see it on the drawing. But if you turned it around, there would be another edge. And then finally, number of vertices. 1, 2, 3, 4, 5. There'll only be 5 because you've got the top point and then the 4 corners at the base. And then finally, the tetrahedron or the triangular base pyramid. Again, you've got 1, 2, 3, 4 faces. Edges, again, just be very careful, but it shouldn't be too bad this time because it's only 3-sided. You've got 1, 2, 3, 4, 5, 6. Okay, brilliant. And then finally, the number of corners, 1, 2, 3, 4. The number of vertices is 4. So hopefully you did well on that and you managed to fill it all out. All right. So a lot of these properties of shape, it's great if you can either remember them or be able to count them using your imagination, be able to see the back and understand how it looks in real life. That would be the best bet. Stops you from having to remember everything. Okay. Your 2D shapes, try and remember quite a few of the properties there, especially in terms of lines of symmetry and angles. Okay, let's move on to plans and elevations then. In your exam, you'll be asked to draw a front plan or a side view or whatever of a shape. So a plan is a 2D view of a 3D solid from above. Okay, so you must remember that a plan, if they say draw the plan, it's always from above. If I was to draw this shape from above, it would just be these top 4 squares. Okay, so it'd actually just be like that. Because if you're looking down on it, you can only see these 4 squares. Okay? All right. However, it's not asking you to do that. An elevation is a 2D view from the side or the front. And it'll tell you which one they want. It will say the front elevation or the side elevation. And it just means draw the view from the front. And in this question, for 2 marks, it says the diagram below shows a shape made with centimetre cubes. On the centimetre square grid, draw the front elevation. And it's pointing to the front. And the front is just this bit here. Okay, so don't be too panicky that you've got to draw a whole shape. It's just that bit. Okay, and that consists of 8 squares. So I can draw that just like that. Okay. And that's it. That's all you've got to do is draw that bit that I've just done on the 3D model onto the centimetre grid. And you get 2 marks. And people miss them out because they get confused and think they don't know what they're doing. All right, let's look at another example. Now it says on the centimetre grid, draw the side elevation. So let's just go back to the picture a second. Side elevation. If I get a different colour, side elevation means from the side, so from here or from here, doesn't really matter. You get the same image. Even though this one's kind of got a step in it, it actually just means pretend that you can't see that lip. Okay, that lip at the top. You can't see that if you're standing right at the front of it, so all you can see is that and that. So those 2 squares there and those 4 squares there. Okay. If you looked at it from this side, you would just get the 6 squares because technically it's that bit there. Okay, so drawing the side elevation would look like that. Okay, so if you're drawing from one side where you've got that lip, you can draw the line there. You don't have to. Or if you're looking from the other side, it could be like that. You get the marks either way, and it's 2 marks. Okay. All right, last one then, and then we've done. So this is a very short lesson. It says here, the diagram below shows a shape made with centimetre cubes. On the centimetre square grid, draw the plan view. The plan. Remember what I said, the plan is always looking down. So what you actually need to draw is this section here. This whole top section there. Okay? Or if you wanted me to like, tell you what, I'll use a different colour because that's just a terrible colour. Okay? So basically you're going to draw this whole section, this top shape, on the centimetre grid at the bottom. Okay? So I'm going to show you how that looks now. I mean, feel free to get some centimetre square paper and have a go. Alright, but it'll look like this. It doesn't have to be drawn like they've drawn it, like at that angle. All you know is that that's 4 sides going down there, and that's 4 going there. Oops. So you can draw your 4 squares, just there, which they've done here. And then these 4 going that way. And then just draw your ladder bit in. Okay, don't feel like you've got to draw it like this, because that would be a nightmare. Okay? Okay, so basically, we've gone through understanding 2D and 3D shapes, understanding some lines, understanding some properties of different triangles and quadrilaterals that you need to try and remember, as well as understanding what a prism is. So, hopefully, you've been able to explain 2D and 3D shapes. Drawn some 2D representations of 3D objects. You're going to do that within your assignment. I've gone through, some nets, and I've gone through some plans and elevations, which means you should be able to do that. And then obviously including plans and elevations there. So what I'd like you to do is go back now to your assignment and have a go at trying to do all of those things practically. Okay? So, well done. I know that was a short lesson. I know that was lots of information as well to take on board. Make sure you took some detailed notes. It's always really important to do that. All right? And I look forward to seeing how you do. I'll see you very soon.